Here we're going to take a look at another example of a joint density function, and we are going to prove this time that our two random variables are not independent but are in fact dependent. We have some weird things happening here, so namely this joint density function is equal to 2 only when our values of y2 are less than or equal to y1 is less than or equal to 1. Also, the value of y2 has to be greater than or equal to 0. And so that's going to have an impact on how we go about calculating the marginal density functions. Right? So let's go ahead and calculate those marginal density functions. So our marginal density function for y1, that marginal density function is going to be piecewise defined. It's going to be an integral. So typically we would go from negative infinity to positive infinity. We're integrating with respect to y2. So what is going to be true about the values of y2? Well, those values of y2, they're going to be bounded below by 0, and they're bounded above first by the value y1. And so we are going to integrate from 0 to y1. So really we want to go over all values of y2 that are allowable, or that have 2 as this density in the joint density. But that only happens when our values of y2 are between 0 and y1. Right? So we're integrating that with respect to y2. When we do that, we end up getting 2y2, but we're going to evaluate that with values from 0 to y1. So we just get 2y2. For the other piece, we're just going to get 0. We'll be integrating 0. And so we get just 0 for everything else. And so this is when we have values for, so we should just get 2y1. We're plugging in y1 for our y2. So when our values of y1 are between 0 and 1, and we get 0 otherwise. To find our marginal density for y2, we have an integral of 2 dy1. And so what's true about our y1 here? So our y1 up here is less than or equal to 1, but it has to be bigger than the value of y2. And so our upper limit is going to be 1, but our lower limit is going to be y2. So we're integrating this with respect to y1. So when we integrate 2 times y1, or 2 times the constant 2 with respect to y1, we get 2y1. But we are integrating that from y2 up to 1. And when we plug these in, we're going to end up with 2 times 1 minus y2. And for the other piece, we're just going to get 0. All right, so we have this as our marginal density for y2, provided the value of y2 is between 0 and 1. Yeah, so those are our two marginal densities. We might observe then that f1 of y1, the marginal density of y1, times the marginal density of y2. That product of marginal densities, that is not going to be equal to the joint density. Because that's not equal to the joint density, y1 and y2 are dependent. Nice. All right, so that's an example where we show that two continuous functions are dependent by finding their marginal density functions and observing that the product of those density functions is not the same as the joint density function. All right, we'll talk to you guys later.